Okay, so now we're going to talk about a concept related to the greatest common factor of two numbers, which is the least common multiple of two numbers. So start with the definition. If we are given two whole numbers a and b, the least common multiple of these numbers, which is commonly referred to as the LCM of a and b, is just the smallest number that is a multiple of both a and b. So just like with greatest common factors, really all we have to understand is the English language meaning of the words least common and multiple to understand the definition of least common multiple. Now, as with the greatest common factor, there is a so-called brute force method that will certainly work to find the least common multiple of any two numbers that is often used in elementary school. It might be a little more reasonable to do this method when the numbers are small, like, for example, 12 and 40. So if we wanted to find the least common multiple of 12 and 40, what we could do is we could just simply write out a bunch of multiples of 12, a bunch of multiples of 40, until we find the smallest one that is a common multiple of both. So multiples of 12 are just simply the numbers we get when we count by 12. So 12, 24, 36, 48, 60, 72, 84, 96, 108, and 120. Now, we should recognize straight away that the first number that we run into in this list that is also a multiple of 40 is 120, so the answer should be 120. It can be a good exercise for students, though, just to, again, refresh their memories on multiples, is just to write out a bunch of multiples of both numbers, just so they can practice. So maybe we will write out a bunch of multiples of 40 as well. Those are easier. Again, we're just counting by 40s, 40, 80, 120, 160, 200, etc., etc. Again, though, we see that the only common multiple that we've obtained in writing these out is 120. Since we're writing these numbers in increasing order, the number 120 is going to be our least common multiple because, again, it is the smallest number that is both a multiple of, in this case, 12 and of 40. And even an example like this, where the numbers were relatively small, 12 and 40, underscores why this is an inefficient way of computing least common multiples. Again, it's always going to get you the right answer, and it can be useful when the numbers are small, but we had to write out a bunch of multiples of 12 just to solve this problem. And you can imagine how difficult this process would be if our numbers were any larger. We'd be writing out multiples all day long, and it turns out that, as with GCFs, there is a much more efficient way of solving these problems using prime factorizations. So suppose we wanted to find the least common multiple of 150 and 140. Now again, by our previous technique, we would have to write out multiples of 150 and write out multiples of 140 until we got one that was in both lists. If we use prime factorizations, however, we'll be able to greatly reduce our work. So again, prime factorizations can be found by using factor trees. 150 is 15 times 10. 15 is the same as 3 times 5. Both of those are prime. 10 is the same as 2 times 5. Both of those are prime. 140, on the other hand, can be broken down as 14 times 10. 14 is the same as 2 times 7. 10 is the same as 2 times 5. Therefore, our prime factorizations of 150 and 140, 150 is 2 times 3 times 5 times 5. 140 is 2 times 2 times 5 times 7. Now, computing least common multiples is a little bit more involved than computing greatest common factors in terms of explaining why the procedure is correct. A very common mistake in computing the least common multiple of two numbers is to simply multiply both of the numbers together. So a common wrong answer to the question, the least common multiple of 150 and 140 is just the product of 150 and 140. Now, if you were to multiply 150 times 140, you would certainly get a number that is a common multiple of both 150 and 140, just by the definition of multiple. But you're not necessarily going to get the least common multiple by doing so. So the question then becomes, okay, well, how do we find the least common multiple if it's not just as easy as multiplying the two numbers together? Well, a good way to motivate the correct procedure is just to start by multiplying the two numbers together and see what happens. If we multiplied 150 times 140 together by their prime factorizations, we would get 2 times 2 times 2, if we're just going to multiply 150 times 140 together, we'd get 3 powers or factors of 2. We would get 1 power or factor of 3. We would get 3 factors of 5 and 1 factor of 7. Again, this is a common incorrect answer to this question, but starting in this way can kind of lead us toward the correct procedure. Certainly, as I mentioned a couple of minutes ago, this number is definitely a common multiple of both 150 and 140. But the question is it the least common multiple? Well, here's a way you can check. If you can remove primes from this list and you still obtain a number that is a common multiple of both 150 and 140, then our original number couldn't have been the least common multiple, right? Because if we remove a prime from this list, we are going to reduce our number. So if we can find a number that's smaller than this, that's still a common multiple, this one can be the least common multiple. So one way of computing least common multiples is actually to do this, to multiply both numbers together in terms of their prime factorizations, and then just start erasing primes until you can't erase primes anymore. So what would that look like if we did that? Well, let's start with the 2's. The question is, could we erase a 2 and still get a number that is a common multiple of both 150 and 140? Well, let's just try it. If I remove that 2, is this number, 2 times 2 times 3 times 5 times 5 times 5 times 7, still a common multiple of 150 and 140? And the answer is yes, right? Both, the prime factorization of 150 is 2 times 3 times 5 times 5. 2 times 3 times 5 times 5 is found inside of this number. Therefore, this number is a multiple of 150. The prime factorization of 140 is 2 times 2 times 5 times 7. And I can find a 2 times 2 times 5 times 7 within this number. So this number is still a common multiple of 150 and 140, yet it's smaller than the number I get when I just multiply 150 and 140 together. So for that reason, the least common multiple of 150 and 140 is not just 150 times 140. I can keep doing this, right? If I can ask myself, is this the least common multiple? And if I can do what I just did, erase primes and still get a common multiple, this will not, again, be a least common multiple. So let's see what would happen if I were to do that. Let's keep going with our 2's. Can I erase another 2? Well, if I erase another 2, can I find the number 150 in this number? Well, 150 is 2 times 3 times 5 times 5. 2 times 3 times 5 times 5 is right here. So this number is indeed a multiple of 150. But it's not a multiple of 140. Because the prime factorization of 140 has 2 factors of 2 in it. And this number does not have 2 factors of 2. So there is no way that this number can be a multiple of 140. Right? So I can't erase 2 2's. I need to just erase one of those 2's that I started with to end up with 2 2's. And now I can kind of carry out this procedure for all of the prime numbers. We see that I cannot erase this 3, because if I erase this 3, this number would no longer be a multiple of 150, because 150 has a factor of 3 in it. What about the 5's? If I erase one of these 5's, notice that this number that I obtain is still a common multiple of both 150 and 140, right? Because 150, again, is 2 times 3 times 5 times 5. 2 times 3 times 5 times 5 is right here. So this number right here is a multiple of 150. 140 is 2 times 2 times 5 times 7. And I can find 2 times 2 times 5 times 7 here as well. So this number is still a common multiple of 150 and 140. So the previous number couldn't have been the least common multiple. I can't erase any more 5's though, can I? Because if I erased one more 5, then this number would no longer be a multiple of 150. I also notice that I cannot erase this 7, because if I erase this 7, this number would no longer be a multiple of 140. So we've landed on, eventually, the least common multiple of 150 and 140. 2 times 2 times 3 times 5 times 5 times 7. Now again, this process is not what we want to do every single time, because it takes too long, right? But hopefully this little exercise of starting with the product of 2 numbers and then erasing primes until we actually get the least common multiple can lead us toward a general procedure. And the general procedure is to form the least common multiple. All we do is we look at the individual primes that make up the prime factorizations of our original two numbers. In this case, the individual primes are 2, 3, 5, and 7. Even though the 150 doesn't have a factor of 7, the 140 does, so we want to include the 7. So the primes that make up the original numbers are 2s, 3s, 5s, and 7s. And we can just go prime by prime and ask ourselves, how many primes does the least common multiple need to have? Well, it's got to have at least 2, doesn't it? Because if it didn't have 2, it would not be a multiple of 140. But if it has any more than 2, it won't be the least common multiple of these two numbers, because I'll be able to do that prime erasing thing that we just did a couple of minutes ago. And we just proceed through the primes in this way. How many 3s is the least common multiple going to need? It's going to need 1, because there's 1 3 in the factorization of 150, but if we take any more than 1 3, our number will not be the least common multiple. How many 5s? Well, there are 2 5s in 150, and there's 1 5 in 140, so we're going to need 2 5s. And how many 7s? There's 1 7 in 140, there are no 7s in 150, so we're going to need 1 7 in the least common multiple of 150 and 140. So if we compare how we compute least common multiples to how we compute greatest common factors, it turns out that for least common multiples, we compare the number of primes that occurs in each factorization, and we use the greater number of primes that occurs. Again, just to illustrate that, there's 1 2 in 150, and there are 2 2s in 140. 2 is the greater number of primes that occurs, so we take 2 2s in the least common multiple. There's 1 3 in 150, 0 3s in 140. 1 3 is greater than 0 3, so we take 1 3 in the least common multiple. There are 2 5s in 150 and 1 5 in 140. 2 is greater than 1, so we take 2 5s in the LCM. And there are 0 7s in 150 and 1 7 in 140, so we take 1 7 in the LCM. That's a general technique.